So we are learning new skills, okay, to help us to solve business problems later. So in chapter 3, we have been learning what? Indefinite integrals and definite integrals, okay? Then indefinite integrals, we saw some samples in section 3.3. And definite integrals, last section we were talking about is this, okay? Then we see how we are going to apply it later. So what the definite integrals talking about is saying, okay, you are learning the definite integral symbol is this. Okay, so if your curve like this, that's your f of x, is above the x-axis. Okay, that means it's a positive values for all the f of x. Okay, then when we learn this, when we take the antiderivative of the curve, okay, this one is saying if we take the antiderivative of the curve function f of x, if we just take antiderivative the function, the model is given to you, okay, from the point A to point B, then what happened? It ends up that it is the area under the curve f of x. So the last section on section 3.1, definite integrals, we were talking about if the curve is like this, if I take antiderivative of the curve, okay, then it happens to be the area underneath the curve. Okay, so that's the concept you need to get it for the last section. It's just given to you and you just saw it, it just happened to be very close. But you don't really know why it's that way. We just give you the conclusion, unless you take advanced calculus, okay, to figure out why it's so. And that's the definite integrals. Then indefinite integrals is not bounded by a and b. We just take the antiderivative like this, right? Then we have a bunch of rules, say how to do the antiderivative, go one level higher. You have a power rule, you have sum and difference rule, you have what? Exponential functions and also log functions to do the antiderivative, right? So for indefinite integrals, then we were doing what? Antiderivative. Then you have an arbitrary constant involved. Then definite integrals is fixed area from A to B for x. Then you take antiderivative in that fixed area. We call it definite integral. Then you take that, the function given to you as a model, when you take a derivative, antiderivative, it happens to be what? The area underneath the curve as well, okay? Then we see how we are going to use those skills for your business world. Then before we do that, another piece we need to talk about it is only section 3.2, the fundamental theorem and anti-differentiation, okay, on your page 70. So that's another concept we need to learn. And it's called fundamental theorem. Anything you call a fundamental theorem, that means it's important. The fundamental theorem of calculus is talking about this way. If f is continuous, all right, so that's the definition. So if f is continuous, that's why we learn what kind of things is continuous. Otherwise, we don't do this thing, okay? F is continuous on this, then if f is antiderivative of f, okay, that means if you take f to the x, it becomes f of x, okay? So f of x is antiderivative of f. Then we have this situation is what? The definite integral for the f of x against x is the same thing as this. Okay? And it ends up, it will be fb minus fa. Okay? Let's see what does that mean. Okay? Also, we use another notation for this one. Okay? We also use this as a notation like this. F x from A to B, it's the same thing as FB minus FA. Okay? You don't know what we are talking about right now, but let's see some examples, then you start to connect. Okay? So if I look at this one, all right, if I have y equals 5 here, I have rectangle here. Okay, so let's do this. That's 5, that's 4. So from 0 to 4, right? That's my equation. F of x equals y equals 5. Okay, maybe I write it this way. Y equals fx equals 5. All right. Then, what do you think this area will be? So if I do area, I should have what? Base times height. 4 times 5, right? That will be 20. Okay, then let's compare. If this one, if I take an antiderivative from A to B, 0 to 4, right? Then my f of x dx will be what? 0, 4 f of x is what? 5 dx. Then if I use the rule of antiderivative of function, constant, right? Constant rule, 5 to go the level higher will be 5x, right? Then if I use this symbol from point A to point B, from time A to time B, from time 0 to 4, then, okay, so that's my what? F of x, big F of x, antiderivative. Then I plug in this, then will be what? 5 times 4 minus 0, plug in 5 times 0, I get what? 20. Okay, so what we are saying is we are just using the simple f of x, right? If I do f of x is 5, I take antiderivative, right? 5 become 5x. So my f of x is what? F of x is 5, which is what? I'm going to find the antiderivative, right? My antiderivative is what? 5x. So if my antiderivative f of x is 5x, I take the derivative of a capital F of x, I end up is what? 5. Okay, then I can just plug in what this one is saying is I can just plug in with this formula, right? Like this, use the capital F function antiderivative 1. If I plug in my value a and b, the result I get is the same thing as the area. Can you see it? It's confusing. It's called what? Fundamental theorem and anti-differentiation. Okay? So they mean the same thing. It means if I do the antiderivative for the curve, which is straight line right now, if I take the antiderivative of this, the result I can use is I find the antiderivative, then I can just plug in my n value from A to B, plug into my antiderivative to get a result of the fixed area. Okay? If you get confused, just remember this thing. Then you'll be okay. Okay? So as long as you can do that, if you want to find some fixed area, it's called definite integral from time A to time B for the antiderivative of f of x. Once you find the antiderivative of x, you just plug in your n value a and b, you minus them, that will be the result, the number for your antiderivative. That's what it is saying. Okay? So if we do some examples, let's see. So we just want you to evaluate this. Okay, if the symbol like this, it means what? You just plug in 5 and 3 into that. That's your antiderivative of that thing. Okay, so what kind of value you should get? You should get this, just plug in the top one minus the bottom one. Okay, so that's just this symbol. we are practicing this symbol. If your f of x is x squared, if we have a bar here from one point to another point, you just plug in them. Okay? Then that will be the value. That's what this symbol stands for. Okay? So if we have this one, 1 to 2 x squared dx, what does that mean? It means, you know, x squared function is like this, right? Parabola opens up. Then 1 to 2 means what? Is from 1 is 1, 2 is 4, right? 1 and 2. So you are finding the definite integral from 1 to 2. That means you are going to find the area underneath the curve for this. That's what this symbol means, right? From your section 3.1, definite integrals. But how do we calculate to find the answer for this? So you do the antiderivative. Are we doing the antiderivative for integral? Means antiderivative. So for antiderivative of x squared is what? X cubed minus divided by 3. Is that right? Then, according to fundamental theorem we are learning in this section is, if you write it this way, you get an antiderivative, then you put a bar here, then you plug in, put these two values there. That will be the answer for this definite integral. Okay? Then, how do we calculate this? This is the same thing as this. So you plug in the n value, 2 to the third power divided by 3 minus 1 to the third power divided by 3. So the result, just do your math, is 7/3. So it says what? 7/3 would be the area under that curve. Okay? So, in section 3.1, we are talking about is the concept, if I do definite integral from 1 to 2, then x squared dx means what? This function, right? Then if I do that, this one is matched with the area underneath the curve. Okay? And this section 3.2 is, if I do antiderivative this, how can I find the answer? Then that's the formula you need to use, is the theorem. You should do what? Find the antiderivative, then put 2n value there. Then what do? You plug in these two values to your function here. Then whatever the number, the result is, that will be your answer for the definite integral. Okay? So, we are learning a new skills to find the answers for the definite integrals. We have to rely on the theorem how to get the answer. Doing that is just plug in, right? But the concepts behind it is very serious. Okay? Next one. Find the area under a curve. So if we have a curve, use your calculator, e to the 2x. What's the e? E is, if x is 0, that would be 1. Okay, so some curve like this. All right, use your calculator to do it. find out. So you want to find the area under the curve between 0 and 1. So x is 0, this curve, y equals what? E to 2x. When x is 0, you plug in, e to the 0 power is 1, right? When it's 1, so e to the second power is some number, right? So it wants you to find how big this area is. How do we find the area underneath the curve? According to section 3.1, it means what? You need to find the antiderivative of this function. If you do that from the 0 to 1, if you do the antiderivative, then it should indicate that's the area underneath the curve, how big it is. Okay? Then how do we find the answer for this? Then we have to do the antiderivative for e to the 2x, which we learned in the section 3.3 at the beginning. Then for the indefinite integral for dx, it will be what? Ex plus c, right? For the exponential function. And if you have 2x there, then you have to divide by 2. Then, right? So it means for antiderivative of e to 2x power, we should get a 2x over 2. For indefinite integral, we need to plus c. But for the definite integral, okay, from 0 to 1, we do this, 0 to 1. Okay, because it's fixed from 0 to 1. Then how do we find the answer from 0 to 1 for this? Then we rely on this section. The fundamental theorem guarantee you, say, all you need to do just plug in. So plug in 1 to the 1 over 2 minus e to the 0 to the 2. Then if you do that, that would be your answer for that. Okay? So that would be half of e squared minus half. So that would be your answer for the indefinite integral. All right. Confusing enough? Okay. Here say, find the area f of x between f of x is this. Use your calculator to do the graph of this, right? From x is 1 to e, right? So the graph looks like what? X cannot be 0, right? X is 1, 2 would be half, 3 would be 1/3, then so use your calculator to see the graph first. Negative, that would be negative. Okay? Then we want to do from what? 1 to e. 1 is here, right? E is what? 2.71 something, right? So e is here. Then it wants you to find the area underneath the curve. We are practicing our skills for antiderivatives, right? Means indefinite integrals and definite integrals. These skills, okay, to do that before we do the business apps. Okay, so we want to find the area underneath the curve means what? We want to find from 1 to e, right? Then area underneath the curve from section 3.1 it says what? You have to take an antiderivative to find the area underneath the curve. Then from section 3.3, we use the skills to find the what? All those tools to find the antiderivatives, all those rules. Antiderivative of 1x is what? Natural log x. Is that right? Then from this section is saying if you take antiderivative of those, the area is such from 1 to e, you do 1 to e this way. Then to find the answer of this, you plug in this formula, so that will be what? Natural log e minus natural log 1, right? Use your calculator, you can find it. Natural log e is 1, natural log 1 is 0, so the answer is 1. Okay? So we are combining everything we have learned so far. Section 3.3 is the what? Indefinite integrals. Okay? It's a bunch. The tools in there, all the different rules, constant rule, right? And those power rules. So you can find antiderivative for indefinite integrals. Then in the definite integrals, they say the area underneath the curve, it happens to be what? The antiderivative. Then in this section, we say we use this different theorem. It's a theorem. Use this theorem to apply to the definite integrals. You can get your value. It's a totally different way of doing things, to calculate things, instead of adding, subtracting, multiplying and dividing in algebra, those basic skills. Well, using more advanced skills. One is called what? Derivative. One is called what? Antiderivative, which is integral, right? Then the integrals have two kinds. One is indefinite integrals, another one is definite integrals. And definite integrals involve the fundamental theorem to get the values. Okay, so next one, find the area between this curve from -1 to 1. Okay, so what should we do? Area underneath the curve is antiderivative from -1 to 1, 24 to 6x squared, right? dx. So then we use what? Sum and difference rule, right? Different tools to do the antiderivative. That will be 24x. Then level higher is 3 divided by 3, so it's minus 6 times 1/3 x to the third, right? Then you do what? -1 to 1. Then you plug in the value, you should get a 44. Practice that, okay? All right, let's see some applications. See how we are going to use these concepts, all those antiderivative things and the fundamental theorem to apply to your business world. Okay, so if we have a situation like this, and instead I say how much total cost if I have marginal cost is what? If I have a marginal cost is what? The derivative of cost, right? If I take an antiderivative, I find my cost function. When I have a cost function, right, I can see how much it will cost me, say up to 300 units or something, right? But if I want to find the total cost of the, just say, oh, I want to find it from unit A to B. What does that mean? So instead of find the total cost function, I say, find me the total cost of function unit if I sell from unit, 100 to 200, how much it will cost you that unit. All right, so it will be what? From unit A to B, right? Then total cost would be what? The antiderivative of the cost, right? That would be the antiderivative of the cost. They are the same, right? So another thing is total accumulation of given rate. Okay, so you have what? Total accumulation at the rate F from A to B. That would be what? Same thing, AB, you take antiderivative of Fx, right? This is the rate of change. Then you find the original function, then you will accumulate them from A to B. So that's how it works. All right, so let's see some apps. It says finding the cost of succession of units. So if a company's marginal cost function is such, marginal cost is this one. Okay, so somebody did a study and develop this function, marginal cost function. What does that mean? It means what? If you produce one more unit at a time, how much it will cost you, okay? So if we do, let's take a look, do the analysis on this, okay? So we are going to estimate, not exactly, right? They want to find the total cost of producing unit from 100 to 400. From what? From 100 units to 400 units, how much it will cost the company, total cost, right? So according to this, total cost unit from A to B will be what? You do this, 100 to 200, right? Then marginal cost function, then you do antiderivative. That's what it's saying. So you do 100 to 200, then 75 square root x to dx, right? Then we do antiderivative you will write what? 75x to the negative half dx, right? Then to do the antiderivative, we use what? Constant rule and power rule. You go one level higher, so take the constant out, then go higher, then will be what? Half, then divided by half, right? Then for the definite integral from 100 to 200, you use this formula, right? From 100 to 200, 400, I thought. That's what I thought. 400. Right? So 75 divided by half is what? 150 x half, 200 and 400. Then to calculate this, we use the fundamental theorem of calculus, right? You plug in the number, so it ends up what? 1500. So what is this one? It's saying 1500. What does it mean? It means what? The cost of producing from the unit 100 to 400 would be what? $1,500. That's what it's saying. Okay? Then we also take a look from an analysis point of view and estimate, because we don't really get it exact, because marginal function is the cost to produce next unit, but not exact, because that's a rate of change at that point. It continuously changes, okay? Only that tiny point. That's why the number not exactly right when we do the analysis, okay? So we are going to evaluate, okay, if I produce for each following units, right? So I'm going to estimate if I produce the unit 100 at that time according to this function, so I would do 100, right? So that will be for the unit 100, to produce the unit 100 at that point, marginal, at margin, it will cost me $7.50, right? We just estimate. Then I'm going to use the good number 225. Okay, at the unit 225, I will do this 225. That will be 15. 75 divided by 15 will be 5. Okay, so if I do the unit 400, I will do what? 75 divided by 400. That would be about $3.25. $3.25. Okay, so I'm just estimating if I produce all those units from 100 to 400, start from 750, each unit as I produce, then it becomes cheaper and cheaper, right? Then how much is total? I'm just going to estimate from beginning to the end. So I do what? 7.5 plus 3.25. I average them, okay? So between the beginning and the end, I average them. Then how many units I will have from 100 to 400? It's about 300, not exact, but close enough. So according to this estimation, so that would cost me what? 1687.56. Okay, so it's close to 1500 because this is a continuous concept, because the this one marginal, right, cost is at that point 750. It's just close enough, not exact. Okay, so this is the estimate to be what? $1687.50, but kind of give you some idea what's going on. For the exact value, should be using the regular formula to do it. Okay? Confusing enough for you? All right, and for the next portion on your page 71, all right, so for function taking positive and negative value. So if we have the situation like this, okay, if your curve, it goes like this. All right, if we want to find the area value underneath the area, so you can do that, fixed area from what? A to B, B to C. But here, because this one is a positive, so you find the area is fine. If you do this way, from B to C, your f of x is here, but that's a negative value for the y. So you will get a negative value. Okay? So we would talk about, so this one will be negative, this one will be positive. So we cannot do from A to C. If you do it together, then you will cancel out some values. So we need to split it. From A to B, you use this curve, then this one, you need to change the sign. Okay? So we will see how to do it later on. Just give you some idea. Okay, if you do this, then that will be negative. Then we need to find the area actually is this one, right? Become negative f of x from B to C. We will show you how to do that later. Just get an idea, and you need to separate to two parts. Then add the two positive values together because area is supposed to be positive, right? Okay, in math, if you see something called fundamental theorem, that means it's quite serious, okay? Then you will get confused. All right, so all you need to remember is 3.3 indefinite integrals, the skills, and the definite integral skills to solve problems, okay? Then in indefinite integrals, you have several tools to do that, different rules, okay? Then we connect the definite integrals for the curve underneath the area. It's the same thing as it takes what? Antiderivative of the curve. All right, then we use 3.2 fundamental theorem to actually calculate the values. That's what we are talking about. Okay, so that's for our section 3.2.